Hello, everyone. Today I'm going to be talking about solar ovens. More specifically, what is the chemistry in a solar oven? I want to start off with project motivation. When I was in middle school, I built a solar oven with my best friend for the science fair. We made s'mores. They were so delicious, and I love that project. So when I heard that we were doing a project with chemistry this year, I instantly thought back to the science fair project. And although I learned how to build a solar oven and how it works, I never learned about the chemistry of it and the environmental impacts. So I'm going to be highlighting those two specific elements today. Environmental impacts of a regular oven. I want to start off by saying that 50% of the world's population burns coal, wood, or crop residue for domestic energy use. And 2.1 billion people cook over wood, animal waste, or charcoal fuels. Why is that a problem? That is releasing so much carbon dioxide into the atmosphere, leading to global warming and other problems such as deforestation, air pollution, and climate change. So, also, it is causing people to breathe in smoke and soot. Keep in mind, this issue is most prevalent in foreign countries and third world countries. Women and children are developing acute respiratory problems from smoky huts, from breathing in too much smoke from these regular ovens. And just to show you guys the big picture, wood burning is 70% of total energy use in sub-Saharan Africa. So imagine how much energy we could save without wood burning by using solar ovens. So speaking of solar ovens, let's learn about the environmental impacts of them. They are a renewable energy source, meaning they don't produce CO2 or other greenhouse gases into the atmosphere. They're cost effective, which is important because a lot of people can't afford regular ovens and it's really expensive. So being cost effective is a big upside to solar ovens. Also, they reduce deforestation, global warming, and improve indoor air quality. An important quote from solar cookers is up to 1.3 million US dollars is the potential global cash saved by reducing CO2 emissions with solar cookers. So, what that means is that we can save up to $1.3 billion by um, using solar cookers because of all the CO2 emissions we are going to be reducing. Um, Chemistry in a solar oven. So there's two main gas laws. We have our Charles law, which uses volume and temperature, and our Gay-Lussac's law, which uses pressure and volume. Starting off with Charles' law, what that says is that the gas gets hotter. When the gas gets hotter inside the oven, it takes up more space. So sunlight heats up the air inside the oven, causing the air to expand, which is trapping more heat inside. Then we have Gay-Lussac's law, which says like when the sun heats up the air inside the oven, the pressure slightly increases. And what does the increased pressure do? Why is that important? Well, it helps the oven stay warmer, which helps the food cook. So I was really interested to learn about these two gas laws that are prevalent in these solar cookers. Here is an image of a solar cooker. It shows how it works. They use solar radiation, which means they use energy from the sun. The energy from the sun reflects on the aluminum, which is known as a reflector, and that reflects onto the pot or the food, which is usually placed on top of a black material, which you'll see later. Um, I also wanted to talk about how much CO2 would be decreased from solar ovens. So I learned that the average household uses 1.8 million grams of natural gas per year. So how many grams of CO2 is that? To do that, I started with 1.2 million grams of methane, which is the natural gas, and I converted that to moles of methane. Because in order to convert to grams of CO2, first we got to get our grams of methane into moles of methane. So I multiplied it by 1 mole of methane over 16 grams of methane, because in 1 mole of methane, there are 16 grams. Then, once I got the amount of moles and methane, I wanted to convert that um, to the amount of grams of CO2. So I used the molar mass of CO2, which is 44, and I saw that 1 mole of CO2 is 44 grams of CO2. Doing those calculations, I learned that 4.95 million grams of CO2 is produced per year by the average household, and that is a lot. So imagine how much CO2 we can reduce with solar ovens. I wanted to mention that unlike natural gas combustion, solar ovens use solar radiation, which, as I mentioned earlier, is absorbing energy from the sun and reflecting and reflection to generate heat without producing CO2. Here is an image of some of the benefits of solar ovens. Um, and then to end, I wanted to recap some of the main points of my project. So it's important to remember how solar ovens use solar energy to produce heat through a physical process. Without solar ovens, no CO2 or other pollutants are released. And using solar ovens can help reduce millions of grams of CO2 produced per household yearly. Sorry. Solar ovens also are eco-friendly and easy to make, and I recommend making one. Like, they're easy to make, as you can tell from this photo. And if you like s'mores, then why not try it out? So I've added instructions on how to make a solar oven. If you want to make one, I recommend pausing the video now and building it. Well, of course, building it later. But pause the video now, take a screenshot, do whatever you need to do. Thank you guys so much. I hope you enjoyed my presentation and learned something important. Bye.